In example 1a, we need to solve the equation shown here for the variable n. So in other words, we need to find the value of n that satisfies this equation. So the process for doing this is we need to get n isolated by itself on one side of the equation. It doesn't really matter which side of the equation we choose, but just by default I tend to choose to move n to the left-hand side of the equation. Okay, so to do this, I want to start by getting rid of the 9 on the left-hand side of the equation. So to do that, I'm going to subtract 9 from both sides of the equation. Since this is an equation, anything I do to one side, I have to do to the other side to keep the equation balanced. So performing that operation, subtracting the 9's, on the left-hand side, I'm going to be left with just 2n. And on the right-hand side, I'm going to have 5n. And then I have minus 6 minus 9, which is going to give me negative 15. Okay? So now the next step is I need to get rid of the 5n on the right-hand side, and basically I need to move it over to the left-hand side. So technically what I'm going to do is I'm going to subtract 5n from the right-hand side, but again, if I do that to the right-hand side, I have to do that to the left-hand side. So carrying out those operations, I'm going to have 2n minus 5n, which gives me minus 3n. And then on the left-hand side, or I'm sorry, on the right-hand side, the 5n's cancel, leaving me with minus 15. Okay, so I'm close to being done. I almost have n isolated on the left-hand side. All I have left to do is divide by minus 3. But again, if I do that to the left-hand side, I have to do the same thing to the right-hand side. So dividing both sides by minus 3, this is going to leave me with n equals minus 15 divided by minus 3 is going to give me positive 5. And so the answer here is going to be n equals 5. That's the value of n that satisfies that equation. If you go back in and check, you can plug 5 into the original equation and see that it works. Let me just show that to you real quick on this example. So if I plug 5 in on this, into this, on the left-hand side, I'm going to have 2 times 5, which is 10, plus 9. On the right-hand side, I'm going to have 5 times 5, which is 25, minus 6. 10 plus 9 is 19. 25 minus 6 is also 19, so you can see that that checks out, and that 5 actually is a solution to this equation. Now, you don't actually have to go through and plug 5 back in, but that's a good way of checking your work, checking your answer when you're done. Okay, so let's move on to part B. Part B is the same sort of problem. We have some equation, and we need to solve for the variable inside of the equation. This one is just slightly more complicated, though, in that it has these parentheses. You see this 25 times x minus 3 term. That's going to make the problem just ever so slightly more complicated. Okay, so the very first thing I need to do when there are parentheses is get rid of them. So basically, I need to take that 25 and multiply it through so that I can get rid of the parentheses. If I do that, I'm going to end up with 10x plus 25 times x minus 75. Now, you need to be careful. There's sort of a trap here that's easy to fall into. But basically what you need to keep in mind is that this 25 has to get multiplied by the x as well as the minus 3. I have to multiply it by both of those if I want to get rid of the parentheses. Okay, so I'm not doing anything with the right-hand side. That's going to stay 275. Okay, so now I'm going to do sort of 2 steps at once. I'm going to combine this 10x plus 25x, which that's going to give me 35x. But I'm also going to add 75 to both sides of the equation so that I can get rid of the 75 on the left-hand side. So when I carry that out, on the left-hand side I'm going to be left with 35x. On the right-hand side I have 275 plus 75, which is 350. So then in the final step I just need to divide both sides by 35 so that I can isolate the x. And if I do that, I'm left with x equals 10. And that's the answer to this problem.